Before we dive into code, let me ask you, have you ever done something repeatedly? Like counting of numbers again and again until we reach our target value? That is basically a repetition. In the world of computers, when we want to repeat something, instead of doing it manually, we use something magical called loops. They help us repeat tasks efficiently without writing the same thing again and again. Now let's see, what is a loop? A loop is a way to tell the computer, hey, do this again and again until I say stop. Just like you have a plan while doing a task multiple times. You know where to start, when to stop, and how to move to the next step. Let's see the loop structure. Loop equals start, then we write the condition, then we update. Let me explain this with an example. Imagine you're counting how many times you blink your eyes in 30 seconds. Blink 1, blink 2, blink 3, blink 4, blink 5, and stop the count after 30 seconds. That's a loop in real life and in programming too. Let's see the types of loops. Let's understand two major types of loops by their behavior. 1. Entry-controlled loop, like for or while. This is when the condition is checked before entering the loop. So, if the condition is false at the start, the loop doesn't run even once. Example, imagine you only eat if the fridge has food. You first check the fridge. If it's empty, you won't eat. 2. Exit-controlled loop, like do while. This is when the loop runs at least once, and then checks the condition afterward. It's like checking your ticket before entering a cinema versus getting in first and then showing the ticket. Real-life loop thinking. Let's try another fun one. Imagine you're climbing stairs. You start at the bottom and take one step at a time until you reach the 10th step. That's a loop. You're repeating the action. Take a step, check if you're done, until the condition is met. Task is to climb stairs. Condition is to repeat until step 10 is reached. Action is one step at a time. That's exactly how loops work. Repeat, check, move. Let's see about the nested loops and theory visualization. Now, let's say we want to print patterns, like stars or numbers in a grid. Here's the trick. When you want repetition inside repetition, we use something called a nested loop. Nested loop means loop inside a loop. Think of it like rows and columns of seats in a classroom. Outer loop, rows. Inner loop, columns. Let's do some pattern printing problems. All right, let's bring this alive by drawing some patterns. Pattern 1, right-angled triangle of stars. Approach, start from row 1, and for each row, print as many stars as the row number. Let's see the first pattern. Pseudocode. For row from 1 to n. For column from 1 to row nested loop. Print asterisk. Print new line. We increase the number of stars with each row. Outer loop controls the number of rows, and the inner loop prints stars in that row. Let's see the pattern 2, number pyramid. Approach. For each row, print numbers starting from 1 up to the row number. Pseudocode. For row from 1 to n. For number from 1 to row. Print number. Print new line. The outer loop handles rows. Inner loop prints increasing numbers. Let's see the pattern 3, reverse triangle. Approach. Start from row 5 and decrease the number of stars per row. Pseudocode. For row from n down to 1. For column from 1 to row. Print asterisk. Print new line. The outer loop decreases with each step and inner loop prints that many stars. Let's see the pattern 4, Floyd's triangle, number sequence. Approach. Keep a counter and print continuous numbers across rows. Pseudocode. Counter equals 1. For row from 1 to n. For column from 1 to row. Print counter. Counter equals counter plus 1. Print new line. Use one variable to keep track of what number to print next. Outer loop equals rows. Inner loop equals elements per row. These patterns aren't just for fun. They build your logical thinking and help you understand nested repetition. Loop building blocks recap. Let's quickly revise how to think for a loop-based approach. 1. Start point. 2. End condition. 3. Update step. 4. Inner versus outer logic for nested loops. If you can answer these 4 in your mind, you can crack any loop-based question. Final thoughts plus motivation. Loops are like the heartbeat of programs. Once you get them, you can automate almost anything. From calculating marks of 100 students, to printing shapes, or even simulating a clock, it all comes down to loop logic. What more you can do using iterations? generating multiplication tables for any number, counting of even or odd numbers in a list, reversing a number or string, finding factorial of a number, creating animations or movement in games. And you can even build basic simulations like traffic lights or digital clocks. This was all about today's lecture. Till then, keep practicing, observe the world with a logical lens, and remember, the mind trained to loop is the mind trained to solve.